Hello again. So, our next problem wants us to find the formula for the area of a regular hexagon with a side length x. So, this is kind of just a generalization of the last problem we did. In the last problem it said the side length was 8. Now it says, let's assume the side length is x, let's try to make a formula out of this. Now, we used the idea that we had equilateral triangles in the last problem by saying that when we draw the lines, it's going to cut the angle in half. But something you should have asked yourself is, how do you know that these diagonals cut the angle in half? How do I know that it splits up this 120 degree angle perfectly evenly? Well, I'm about to show you why. So we know that each interior angle is 120 degrees. Based on our formula for finding the angles of the polygon. Now, if I split this hexagon in half, we get a trapezoid. And a trapezoid is a type of quadrilateral, and all quadrilaterals, the angles have to add up to 360. That's what we proved before spring break. So, if all the angles in this trapezoid add up to 360, and we have 120 and 120, which is 240, then the only way we get 360 is if we have two 60-degree angles here. Because then we get 120 plus 240 gives us the 360. So that same logic can be applied to show that all of the rest of the angles are cut in half by these diagonals. That's the logic that shows that we have these 60-degree angles. Now, continuing, we have that the area of an equilateral triangle is equal to x squared, the side length of the triangle, times the square root of 3 over 4. That was mentioned in the last video. Again, if you need to remember where we got this formula, it's from the first day we did 30, 60, 90 triangles. So, what is the side length of the triangle? It's literally our x value here in the problem. Now the area of the hexagon is just this very same thing, except we have 6 triangles, so we just multiply this entire formula by 6. Now 6 over 4 reduces to 3 over 2, so we are left with 3x squared times the square root of 3 over 2. And that is the formula for the area of a regular hexagon. So, again, just take the problem, break it down into what we know, and it's a relatively simple procedure. Just use the information that we have learned about to simplify the problem and get a result that makes a lot of sense.